So two of you. Fine. So we'll start. That we have completed electrochemistry, right? So we'll be starting with solutions today. So we'll directly go for problems. So you know what or not is there. Like the first part talks about the different methods of expressing concentration, right? Say in terms of molality, mole fraction, mass percentage, volume percentage. That is the first part, and also about Henry's law, right? And then the second part talks about why is the camera little like this? Can I keep better? Right. So the second part talks about Raoult's law, right? And then it also talks about the colligative properties. So the last part talks about Van 't Hoff factor. So these are all the things which are present in this chapter. So we'll see all the areas. We'll do all the areas. Okay. So we'll do some problems.
Sir, for actually speeding up, sir, like in the colligative properties, can you only do the questions of Van 't Hoff factors involved, sir? Because generally, this other this thing is generally decent.
Oh, okay. Anyways, we'll do questions on Van 't Hoff factor also. But like as you said, it's going to be simple formula substitutions if it's going to be normal colligative properties, right? But anyways, we'll do manual problems there, and we'll do more number of problems in case of Van 't Hoff factor. That we'll do. Okay.
Sir, because in CBS itself, we've done it so many times. Like Van 't Hoff factor is only deleted question for us.
Yes, sir. Van 't Hoff factor is deleted.
Oh, Van 't Hoff factor is deleted. Okay, fine. We'll see it. Maybe I'll teach you also. I don't think you know anything about Van 't Hoff factor, do you?
Sir, just a little, sir. Just can you just explain what
Sir,
abnormal?
I was taught in the other coaching, sir. So
okay, anyways, I'll teach you. I will teach you Van 't Hoff factor, then we'll do questions. Okay, fine. Fine. Right. So they're telling there is a glucose solution, right? This glucose solution is having a concentration of 1 m. You know, capital M represents one molarity, right? 1 m. Capital M is molarity. So I want to know. No, I'm sorry. So this is one small m. That is the molality is 1, right? One small m represents molality, right? So I'm asking, what is the mass of glucose present in 1 kg of this solution? That's the question, right? So they have given that the glucose solution is a concentration of 1 small m, right? And I'm asking you, what is the mass of glucose present in 1 kg of this entire solution? I take 1 kg of the solution. In that, how much? What is the mass of glucose present? Is the question. So people, right? So knowing the formulas alone will not help, right? Maybe you know what is the formula for molality, mole fraction, and all these things, but knowing the knowing the formulas alone will not help, right? You have to know how they are defined, right? Lot of times directly questions asked from the formulas. Like this kind of questions, you have to know what is the definition of that particular concentration term, right? Okay, can you tell me how do you define molarity? Molarity, capital M, how do you define it?
Number of moles of solute per 1 liter of solution.
That's it. So if I have 1 liter of a solution, right, in that how many moles of solute is there, right? That is what is the definition for molarity. Okay, molality. L, small m.
Number of moles of solute given for 1 kg of solvent.
That's correct, right? So there we use volume of solution in molarity. Here we use mass of solvent, right? See how you compare. That is number of moles in 1 liter solution. This is number of moles in 1 kg of solvent, right? So that is my molality. Okay, fine. So if you know this stuff, you'll be able to easily, again, if it's going to be mass percentage, if it's going to be in terms of percentage, you assume that in 100 grams of the solution, right, in 100 grams of the solution, what is the mass of the solute? Percentage. If I have total solution, in that how much is the solute is what is my mass percentage into 100. That fraction into 100 is what is my mass percentage, right? Okay. So in this question, they're asking, if they have asked you what is the mass of glucose present in 1 kg of solvent, what would have been your answer for this question? If I had asked you what is the mass of glucose present in 1 kg of solvent, what would have been your answer?
Molar mass of glucose.
That's it, right? So what do you mean by this 1m? Means I have 1 mole of C6H12O6 in, if it's an aqueous solution, I should say that 1000 grams of water is present. That is what by this statement 1m means, right? Okay, but they're not asking that. If they're asking that, if it's in 1 kg of solvent, then I know 1 mole of glucose, how much is the weight? 1 into the molecular mass of glucose, which is 180, right? Okay, but they're not asking that. They're asking me what is the mass of glucose present in 1 kg of solution, not solvent. Okay, fine. So now what you understand is this statement is okay for us. Okay, now yeah, right. So this statement is 1, or I would say 180 grams of C6H12O6 is present in, can it's present in 1180 grams of solution. Can I say this? Now how am I saying this? Now we know total mass of solution. If we just calculate what is the total mass of solution from this data, 1m, what do we get? I have 180 grams of glucose present, right? And I already have 1000 grams of water, right? So what is the total mass of the solution? Total mass of solution is mass of glucose plus mass of water, that is 1180. 1000 plus 180, which will become 1180. Now what they're asking is, if I have 1000 grams of this solution, what is the mass of glucose? That's what you need to find. Is it not 180 grams of glucose in 100 grams, 1000 grams of water? But that is not required for me. They're asking me in terms of solution. So 180 grams of glucose is present in 1180 grams of solution. That is the mass of glucose plus a solvent, water. Right. Now they're asking how many grams of glucose is present in 1000 grams. So you can cross multiply and find the answer. Right. So that would be x is equal to 1000 into 180 divided by 1180. This is what would have been the answer to this question. Everybody understood what I'm trying to do here? Right. I hope everything is okay. Right. So if you calculate it, you should be getting 153 grams as the answer to this question. Right. Okay, next question. Okay. So there is a ethanol solution, C2H5OH solution, which is 20% M by V. Okay, it's 20% M by V, mass per volume. Okay, fine. And they are telling that the density of this solution, this is a solution, right? Now this solution's density is 0.977 gram per ml, right? Okay, and density of ethanol alone, it's not in the solution. I know ethanol is also a liquid. Its density when ethanol is alone there is 0.78 gram per ml. Now what I'm asking is, what is the M by M percentage of the C2H5OH solution? Okay, they have given you M by V percentage, right? And they're asking you what is the M by M percentage, and they have given you some density values for this question. Work it out. I
So
hope
that's
you guys.
0.977, sir.
Yeah, 0.977. Yeah, gram per ml. Now you just need to know what is the formula. If you know the
So
formula,
is
you
it
know.
20 grams of ethanol and 80 ml of water, sir?
What this means?
Yes.
No, that what do you mean by M by V percentage means it is the mass of solute present in 100 ml of the solution. So if I have 100, so what do you mean by this is 20 grams of ethanol is present in 100 ml of the total solution.
Sir, so it's 80 ml of water, no, sir?
No, we cannot say that, right? How will you
Oh,
say
okay.
that? Yeah, we can tell the total solution, total volume, total solution. I mean, total volume of solution is 100 ml. That we can tell, but we cannot separately tell. For that only they have given you this. Okay. So this particular statement means 20 grams of C2H5OH is present in 100 ml of the solution, right? So what I can understand from this is the mass of C2H5OH present in the solution. Now, from this data, total volume of solution is 100 ml, right? Now they have given me density of this solution only, right? So please understand, for mass by mass percentage of the solution, what is the formula? It is mass of solute. In this case, solute is what? Solute is C2H5OH divided by mass of the whole solution into 100. This is what we need. Correct. Right. Now this term we already found out, 20 grams. Is it not? Right. Now what I need is, or if it's, oh, I'm sorry, 1 second. Guys, I'm sorry. This is V by V. I'm really sorry. Okay. Okay, this is V by V. Okay, not M by V. So I'm really sorry. This is not 20 grams because now why did I? Now they didn't give you anything like that in question. They're just giving you 20% by volume ethanol. But you have to understand, right? It is going to be M by V or V by V. So obviously they wouldn't have given this density of ethanol if it was M by V because you can directly calculate what is the mass of ethanol. Right. Okay. So this means I have 20 ml of ethanol in 100 ml of solution. Now you can tell, Varun, you can tell that 80 ml of water is there, 20 ml of ethanol is there. Now you can tell because both are volumes. Okay. So anyways, so now I have two things. One is the volume of ethanol alone, and next one is the volume of the solution, entire solution. Now I need to find the mass of these two, right? I can easily calculate. So the mass of solution is equal to density is equal to mass by volume. So mass is equal to density into volume. Okay, so density of the solution into the volume of solution. The volume of solution is 100. Right now, density of solution is given as how much? 0.977. So 0.977 into 100 will become 9.77 grams. Okay, mass of solution is 9.77 grams. Easy. Now this how will you find out? Now
So
I know I have
97.7.
correct 97.6. Right. So 97.7 grams. So now how will you calculate mass of solution, solute ethanol? Now I know what is the volume of ethanol. So if I calculate mass of C2H5OH will be density of C2H5OH into whatever the volume is 20. So it's going to be 0.78 into 20. So 0.78 into 10 will become 7.8. 7.8 into 2 will become 7.5 will be 15. 15.6. Right? Yeah, 15.6. So that's it. Now you got both the values. 15.6 divided by 97.7 into 100. And this is how you do the problem. Okay, right? So in this question, they have not given it as M by V or V by V. They have just given 20% by volume. That's what they give. That's the only thing they have mentioned. Right, but you have to understand by looking at the question that okay, this is V by V or M by V depending on what data is given in the question. If this density of ethanol was not given, then I can assume that it is going to be M by V. But if at all they have given it, we try to use it. In that case, it definitely be V by V. Okay, right. I hope you understood. Okay, so we'll just do two more questions in this kind of concentration problems, and then we'll go to Henry's law, Raoult's law, and stuff. Right? Okay, can I wrap this part? Is it done?
Yes.
Okay, cool. Okay. Okay. So they're asking, I have 1.38 m CH3OH solution. Okay, right. Now I'm going to dilute it. I'm going to dilute it by adding water. Okay, to make it to 1 m CH3OH. Right. Now the question is, what is the mass of water which should be added to the solution so that this becomes 1 m? Go for it. Have you understood the question? I have 1.38 mCH3OH. I'm going to dilute it by adding water to make it 1 mCH3OH. Now the question is, how much amount of water? What is the mass of water which has to be added to the solution so that it becomes 1 m? See, there are two ways of diluting a solution. One is by removing solute. Removing some amount of CH3OH will again reduce the concentration. Or you add more amount of solvent. That is also will dilute it. But generally we don't go by the first method. If you want to dilute, we just add more water, right? So what you have to understand is you are not touching anything about CH3OH, right? That's the most important point here.
Sir, it's a wild guess, but is it 38 grams?
38 grams. Yeah, you are okay. We'll see. Right, it's not 38. The options given is 380. So that option is there. Okay, we'll see. Right, fine. So from this statement, what do I understand? I understand that 1.38 moles of CH3OH is present in 1000 grams of water. So that's the solvent here. Hope you understand. Right? Okay. Now, when you are going to add more amount of water, this amount is not going to change. The 1.38 moles of CH3OH is going to be still there. What you are just changing is this. Is it not? Okay, fine. So if I calculate the new molarity from this, okay, small m is equal to 1, right? Small m is equal to 1, which is equal to number of moles of CH3OH divided by, I already had 1000 grams of water. Now I'm going to add something extra, right? So let me keep it as x. So total is 100 plus x. Now, why am I writing this? Is because already I have 1000 grams. How much extra I'm adding is what we need to understand, right? So 1000 plus x into 1000, because we are using everything in terms of grams. If you use kilograms, it's okay, but now you're using grams, so that's why you're putting 1000. That's it. So what is the number of moles of this? Number of moles of CH3OH is still 1.38. So 1 is equal to 1.38 divided by 1000 plus x into 1000. This is what that's what we have. So if you do the calculation somewhere there, I have 1000 plus x is equal to 1380, right? So what is x? X is going to be 380 grams. So 380 grams of water you need to add to this solution so that the concentration of solution becomes 1 smaller. It's just one formula application. You just have to remember that this does not change. Already I have 1000 grams of water, so I'm adding some more. That is x. You know what is the molarity of the solution? That is 1. That's it. Get the answer. Okay, right? Fine. One more question in this area, and then we'll move on. Okay. So if you just take this down, I'll drop this part. Guys, have you started doing the mock tests?
Not yet, sir. There's a lot of practical work, sir. We have to submit a breakout tomorrow.
Okay.
After tomorrow, sir.
Okay. But you have your exams on 24th, 20th. Today itself is 18th. You hardly have 1 week. Okay. Fine. So we'll drop this part. I hope it's done. All right. So the next question is, I have 275 ml of 0.2 m KNO3 and 325 ml of, where are you? Yeah, 325 ml of 0.4 m MgNO3 twice, right? And I have 400 ml of water. Okay, and I am mixing all these solutions. I'm adding all these things together. This solution, and this much amount of water. Right? Now, what I need to know is what is the concentration of NO3 minus ion in this. Concentration means obviously talking about molarity. Right? Okay, we have mixed all these solutions. Right? I'm asking you what is the concentration of nitrate ion in the solution, in the mixed solution. So what you have to do in these kind of things? When I'm say I have two HCl solutions, 1m solution and 2m solution, and if I mix them together and I ask you what is the new concentration of the new HCl solution, say some 100 ml of 1m, some 200 ml of 2m, right? If I mix it, what will you do? How will you find the new molarity?
Add the moles, add the volumes, then fine, sir.
Add the moles, add the volumes. Yeah, makes sense, right? So obviously you have to understand that the total volume of the solution is going to get added. Say 100 plus 200 will be the total and total volume of the solution, right? Now what you have to do is you have to calculate what is the number of moles of HCl coming from the first solution, that is molarity into volume. Same way, calculate what is the number of moles coming from the second solution, molarity into volume. That is the total number of moles of HCl divided by total volume is the new molarity of the new HCl solution. The same thing we have to do. You have to calculate what is the number of moles of NO3 from this. Now calculate the number of moles of NO3 from this, and total volume is there. You divide it by the total volume, number of total volume. You are going to get the molarity. Okay. See, from this, if I calculate what is the number of moles of KNO3, can I say it will be 275 into 0.2 into 10 to the power minus 3. Hope you understand why again. Because we will be using 1000 of our molarity calculations that will come here, divided by. Okay. Or you can just keep it as millimoles. You can just rub this part. And this many millimoles you write. Millimoles means 10 power minus 3 moles. Either way, it's going to be right. Okay. Now, from this, say you see KNO3 will give me 1 mole of K plus 1 mole of NO3 minus. So 1 mole of KNO3 gives 1 mole of this. So from this, I can directly say the number of moles of NO3 minus coming from KNO3 is again going to be the same thing, 275 into 0.2 millimoles. Right? Now, if I want to do this for this solution, I can write number of moles of MgNO3 twice will be equal to 325 into 0.4 millimoles. But what you have to understand is from 1 mole of MgNO3 twice, I will get 1 mole of Mg2 plus 2 moles of NO3 minus. Please understand. Right? So in this case, this is the number of moles of MgNO3. So if I have to calculate what is the number of moles of NO3 minus coming from this, it will be 2 into 325 into 0.4. Is it not? Okay. Number of moles of MgNO3 is this much. And from 1 mole of MgNO3, I get 2 moles of nitrate ion. So the number of moles of nitrate ion coming from MgNO3 is 2 into 325 into 325, 325 into 0.4 millimoles. Okay, right. So I think I'll just rub this part. Right. So now total number of moles, I'll write NT will be this value plus this value. So that would be 275 into 0.2 into this here is 2 into 325 into 0.4. Correct? Right? Now total thing into 10 to the power minus 3. I'm sorry, it's not into, it's going to be plus the number of moles of NO3 minus coming from this, number of moles NO3 minus coming from this, into 10 to the power minus 3 because both of them have that, divided by now the total volume. Total volume is how much? 400 plus 325 will become 725. 725 plus 275 will become 1000. Right? It's 1000 ml. Right? 1000 ml. Now, since you're again using ml in the numerator, I have to put 1000. So this and this gets cancelled. 1000 and 10 to the power minus 3 gets cancelled. So all this divided by 1000 is what is going to be the answer. So 275 into 2 will be how much? 275 will be 2 will be 550. Right? So basically it will be 55. 55 plus 325 8 times. Or 325 into 2 times would be 650. 650 into 2 times will become 1250. Correct? No. 650. 1300. 1300 into 2 will become 2600. So it is going to become 260. 260 divided by 55 into 1000. Into 1000 is there, divided by 1000. This would have been your answer to the question. Okay, right? So pretty simple. They just added the number of moles coming from each solution divided by the entire volume. Now what people will do is they'll miss this 400 ml of water that has to be added along with the volume, total volume. Okay, so that you take care, you will be able to get the answer to this question. Okay, right? We'll move on to the next question. Right, so even though it's clumsy, I think you'll be able to understand what we did here. This is not number of moles, this is actually the molarity. We directly calculated the molarity of NO minus. Okay, move on. Okay, this is going to be a formula substitution, but still we just do it. So I have an unopened soda, right? I have an unopened soda, right? Now they are telling the mole fraction of CO2 in this unopened soda is 0. Oh, it's not mole fraction. They are given in terms of concentration, molality. So the molality of CO2 is 0.0506 m. Right. Now they're asking what is the pressure of CO2 inside this, given that the KH is 0.034 mole per kg per bar. Right. So first of all, you need to know what is Henry's law. Henry's law talks about solubility of a gas in a liquid, as simple as that. Right. We have to talk about solubility of a gas in a liquid. That's what you're talking about. Right. What he says is the solubility of a gas in a liquid is directly proportional to the external pressure. That's it. That is one way of looking at it. See, I have open. This is an open vessel. Assuming this is an open vessel, right? Say I have a liquid, okay, or say what even if it's a closed liquid, assume whatever it is, right? Or okay, no issues, right? So this is I have a liquid. Into this I am going to dissolve a gas, right? So whatever is the external pressure you supply, right, the solubility of this gas is going to increase in this. That's what he says. Okay. Now what if it's a closed system, right? In this case, you have to consider external pressure increases, the solubility of gas increases, right? Now, if it's a closed system, please understand, here I'll have some gas. The solubility of this gas is directly proportional to the partial pressure of the gas. Hope you understand. Now, you see, here the variable is external pressure because it's open to the atmosphere or whatever, open to some pressure, right? Now, in this case, it's a closed system. So there is no question of external pressure here. We have to talk into account of the partial pressure of the gas inside the system. Okay. So like in the this is an unopened soda. So unopened soda is again going to be a closed system, right? So in that closed system, obviously the solubility of CO2 is going to depend on what is the partial pressure of CO2. Either way, if you use this or this, right, you will be getting solubility X as KH into P. Or am I right? Oh, I'm sorry, this should be ulta, right? So P is equal to KH into X. Am I right? Okay. Now this pressure again will vary depending on whether it's going to be an open system or a closed system. If it is open system, you have to use external pressure, right? If it is closed system, this pressure is going to be the partial pressure of the gas used, right? And this KH is what is your Henry's law constant or Henry's constant, and this is X is my solubility. Now this X, what you would have studied in your NCRT is you can have it only in terms of mole fraction, but in this question you saw it is given in terms of molality. It doesn't matter, right? Whatever be the unit of solubility, whatever be the concentration term you take for solubility, right, the KH value will take care. KH value you see here, if in your books, if you would have checked, you would have just have whatever KH value will be in terms of per bar per -1, because there will not be any unit. Why? Because you would have used I think it's just bar. Oh, I think bar should come in the numerator. So mole bar per kg. Now, hope you understand why. Right?
Sir,
I have.
Sir,
Yeah.
sir. I think it's mole fraction is equal to P into KH, sir.
Oh. Okay. KH into. Yeah. Okay. Fine. Maybe I just exactly don't remember, but I know they are directly proportional. So what you're telling is X solubility is equal to KH into P. Is that what you're telling?
Yes, sir. I googled it just now.
Okay, okay, cool. Then it should be correct. Okay, bear with me. A little problem there. Okay, so anyways, it's gonna be then per bar only. So kg per -1, bar per -1. Okay, correct. Okay. So what I was telling is, okay, this solubility which you're talking about here can be any concentration term. It can be molarity, it can be mole fraction, it can be molality, it can be anything, right? But what you have to understand is what you have to look into what is the unit of kH. Now you see it is mole per kg per bar. So you can see mole per kg means it is taken care, right? The concentration is given in terms of molality, and the kH is also in terms of molality. So don't worry about it. 99% will be like that only. Okay, so you just have to put the values in the equation and find the answer. So x is the solubility. That's what we need to find, isn't it? No, they have given solubility is what is my concentration, right? So 0.0506 is equal to whatever the partial pressure of CO2 into 0.034. That's it. So partial pressure of CO2 will be 0.056 divided by 0.034. Right? Okay. So that is your Henry's law. Now again, can have two variations of Henry's law depending on what is the condition. Whether I can have an open source, open system or a closed system. At that time, what kind of pressure you use will be different. For closed system, it is the partial pressure of the gas inside the system. For open system, it is equal to the external pressure. Right? Okay. Next question. So that's it. We'll directly move on to your colligative properties. Okay. Right. Now, please understand, people. Your first colligative property, that is your Raoult's law. Sorry, your relative lowering of vapor pressure. Right. So I think you have had this formula like this. Right. See, you have just have to remember two things. First is Raoult's law. Right. Now, Raoult's law talks about the vapor pressure. Okay. Right. Raoult's law talks about the vapor pressure. What it says, vapor pressure. Yeah. So the PA, vapor pressure, right, is directly proportional to the amount of the component present in the liquid phase. Please understand. If I write it as PA is directly proportional to XA, this XA is the mole fraction of A in liquid phase. Very, very important. Right? This is the mole fraction of A in the liquid phase. Same way I write PA, or I can even write PA is equal to PA naught into XB, sorry, XA. Right? Same way I can write PB is equal to PB naught into XB. Again, XB is the mole fraction of B in the liquid phase. Be very careful. Okay, right? And I know what is PA naught and PB naught. PA naught and PB naught are the pure vapor pressure of the pure liquids. A alone is there. What is the vapor pressure? B alone is there. What is the vapor pressure? That is your PA naught and PB naught. Right? Okay. Now, what you have to understand is when you want to solve questions with respect to this, or if you use your relative lowering of vapor pressure, you are going to get the same answer. And I would prefer to use your Raoult's law only, because like say you have del P divided by PA naught is equal to XV is what you would have done for your relative lowering of vapor pressure. Right? Now, what you have to understand is this is actually derived from all of these. Is it not? So I would suggest don't use this. You try to go with these two, and now with total one. PA is equal to PA, P total is equal to PA plus PB, or P total is equal to PA naught XA plus PB naught XA. Okay. So these three equations alone, this is not going to be much useful. Like if you do the problem, you'll understand. Okay. So anyways, so these three things you have to know for doing the problems. Okay, we'll do. Okay, please type on the question. So vapor pressure of pure water. Vapor pressure of pure water is 23.8 torr, TORR, right? Vapor pressure of pure water is 23.8 torr, right? Now they're asking, what is the vapor pressure of the solution? What is the vapor pressure of the solution? Containing 6 grams of urea, right, and 68.4 grams of sucrose and 10 moles of water, right? So I have a solution containing all this, and I'm asking you, what is the vapor pressure of this solution? Okay, and they've given you, when I have pure water, what is the vapor pressure?
So what's the value of vapor pressure?
23. So P naught of H2O is 23.8 torr.
Okay, sir.
See, you have to consider only water here, right? So you just have to use only one equation. That equation is vapor pressure of H2O is the pure vapor pressure of H2O into the mole fraction of H2O. That's it. This is the only equation you need to use. That's it. Everything is in terms of H2O. And you can ask me, sir, what is this partial pressure of H2O? If I don't put a naught, what do you mean? That means I have some other substance also in it. This is what is the solution basically, right? P of solution is equal to the pure vapor pressure when I have water alone, and then you have added. So in this case, you have to put what is the mole fraction of water. Okay, right? You can easily calculate what is the mole fraction of water. So hope you know what is the formula for urea. Formula for urea is NH2CO NH2. Molecular mass will be 60. And sucrose formula is C12H22O11. Right. So this would be 0.1 moles of urea, and sucrose is C12H22O11. What is the mass of this, molecular mass of this? Any idea? 12 into 6 is 72. 72 into 72 plus 22 is 99. 99 plus oxygen is 16, 160, 160, 176. So how much? 99, is it not? 72 plus 22 is 99 plus 1.
275, I think so. Yes, sir, 275.
No, what I'm asking, how is it possible? That's a C12, 72. Oh, 72 plus 22 is 94. Right? 72 plus 22 is 94. Okay, so this will be 270.
Yes, sir.
Are we doing it correctly? C12H22O11. 12, 6. Oh. Totally wrong. It's 12 into 12 become 144. 144 plus 22 will become 166.
Sir, it's 342.
Yeah. 342 grams. Right? So 342 divided by 68.4 divided by 342, I think would be how much? How many moles?
0.2.
0.2. I think
Yes, sir. 0.2.
1 by 5th of 342 is what is 68, isn't it? 68 into 5 is how much? 68 into 5 will be 300 plus 42. Yeah, this is 1 by 5. 1 by 5, correct quantity. What are you telling us? Oh, 0.2 moles. Right? Okay. And 10 moles of water. That's it. So mole fraction of water is equal to number of moles of water divided by total number of moles, which will be 10 plus 0.2 plus 0.3 will become 0.3. So 10 divided by 10.3 is what is the mole fraction of water. Now every value is given. This value is given as 223.8 torr. Right? So that's it. You can go for it. You'll be getting the answer. Okay. So direct formula substitution. You just have to understand. You're using only Raoult's law. Do not go for relative lowering of vapor pressure. Use only Raoult's law. Okay. Right. So we'll go to the next question. We just do the calculation here. Okay. Next question. So they have given at 300 Kelvin, I have a liquid which is A. The basically PA naught value is given to us as 575 torr, and PB naught. There is another liquid B which is having a vapor pressure of 390 torr, and they are telling mole fraction of A in vapor phase is 0.5. No, 0.35. Okay, mole fraction of A in vapor phase is 0.35. Now I want to know two things. Two things are, what is the mole percentage of A in liquid phase, and the total vapor pressure, T total. Two things you need to find. Okay, right? See, this is a very important statement. It is the mole fraction of A in vapor phase, not in liquid phase. And please understand, for Raoult's law calculations, you need the mole fraction of the components in the liquid phase, not in the vapor phase. Right? Think about it. So which law can you use? If I'm not able to use Raoult's law, obviously I have to use Raoult's law for calculating the total pressure here. That is okay, total vapor pressure. Right? This is total vapor pressure. You can even write it as VP total, but we generally write it as P total. That's why I didn't write. So I have to find what is the total vapor pressure. Okay. So for finding total vapor pressure, you have to use Raoult's law. No other go. Right. But it's not only going to be Raoult's law. It is going to be some other law which has to be used here. Which law you have to use? Which law? I have gases, mixture of gases. Mixture of gases means the vapors of A, vapors of B are going to be in the vapor phase. And they have given you the mole fraction of one of the component in the vapor phase. What can you think about? What law can you think about?
Dalton's law of partial pressures.
Absolutely. Right? You can use Dalton's law of partial pressures. Hope you remember the equations for Dalton's law of partial pressures. I write P total is equal to PA into XA. Right. Now PA is the vapor pressure. PA is what is the pressure of the gas in the mixture. And this XA is what? XA is the mole fraction of A in gaseous phase, in vapor phase. Right, that is the difference between your Raoult's law and Dalton's law of partial pressures. Okay, so oh sorry, I'm writing it ulta. PA is equal to P total into XA. Same way PB is equal to P total into XB. Right. So for your for you not getting confused, use XA and XB in the case of vapor phase. Right, and use YA and YB in liquid phase. So just to avoid confusions. Okay, go for it. Anyways, I'll help you. And hope you understand the relationship between the mole fractions. If you know one mole fraction, the other mole fraction is known. One minus the known mole fraction will be the mole fraction of the other one. Right? So use this X in terms of vapor phase, Y when you have liquid phase. So I wrote X here. X means obviously it's going to be vapor phase. There also I used X only, vapor phase. So you have to combine both the equations and use it in some way. It's all this, you know the formulas. It's pure mathematics. That's it. Okay, can I do, or do you want some more time? Okay, I'll just write on the question. I'll do it. Okay, right. So I just listed what are the equations we're going to use. Right. Say one is PA or P total. I'll directly write P total is equal to PA naught XA plus PB naught X. Oh, I'll write Y because we have chosen Y to be in liquid phase. Right. YA, YB. I don't know both the values. I don't know YA, I don't know YB, but what I know is PA naught and PB naught. That is given in the question. Okay, fine. Now another thing is there, P total or say PA, right? PA is equal to P total into XA. Same way PB is equal to P total into XB. This is coming from Dalton's law. Okay, right. Fine. So we have to do something. Okay. And I have one more thing also. P total, I can write it as PA plus PB. Either way. Right? And all this PA, PB, P total, all these are vapor pressures. Okay. Okay. See, this is actually going to be PA plus PB, where PA is this much, PB is this much. Okay. Now, what I will do is I will write the equation like this. How will I write? I'll write P total, this one, P total is equal to PA. What is PA? PA in terms of Dalton's law, right? PA in told, PA, no, not gonna work. Right. Somehow we did it right. Oh God, wait, I forgot. One second. First of all, I write everything in terms of one variable. So this, let me write it as 1 minus YA, because I need to have only one equation. That's why. Okay. Now I have one more also. PA is equal to PA naught YA, and then that's what I need. PA and PB is what I need. Okay, and I have one more. PA is equal to P total into XA. Right? I think I'm done. So if I just equate these two, what I have is PA naught into YA is equal to P total into XA.
So you can substitute the first equation in the last, right?
Now, so we can substitute this equation in this.
In the last
Definitely.
equations.
Last equation is which one? This one or this one?
The one below.
This one.
Last one.
This one.
PA not. Yeah.
PA naught YA is equal to PT into XA. So substituting this in this.
Yes,
So I
sir.
can
So
use
we'll
for
get
PT.
YA.
Okay, understood. Yes. Right. So I can write PA naught into YA is equal to P total. In terms of P total, I write this PA naught YA plus PB naught into 1 minus YA. But I know only XA. Into a total thing into XA will come. Total pressure into XA. Right. Oh yeah, that's it. So I know all the variables. I know PA naught, PB naught. I know XA. The only thing which I don't know is YA. So it's done. That is the liquid phase this thing. Yeah, done. Yeah, that's a good work. Okay, so if I have to calculate, this is gonna be 0.35. XA is given in the question as 0.35. Let me do that. So PA naught is 575 into YA is equal to 575 into 0.35 into YA plus what is the PB naught value? 390. 390 into 1 minus 0.35 will become 0.65 into 0.35. What did I do? Why did I do YA again? Am I doing it correctly? YA is what I have to find. Oh, sorry. Right? So it will be PA naught is 575 into 0.35 into YA plus PB naught into 0.35. So 0.35 into 390 minus of 390 into YA into 0.35. I just expanded the equation, right? So I'll just take the YA terms alone here. Okay, so if I just take the YA terms, we will have okay, so this only will be remaining this side, rest all will go this side. So it will be YA if I take common 575 minus 575 into 0.35 and I have plus 390 into 0.35 and this is equal to 0.35 into 390. Okay, so all this has to be calculated and you can finally calculate YA. YA will be this value entirely divided by that value, and that is what is your mole fraction of A in liquid phase. That into 100 is what is the answer, mole percentage of the question. And then you can directly use, now you know XA and YA, you can use your total this thing, you can use it to find your total pressure. PA naught you know, YA you know, YB you know, you can just find out your total pressure. Okay, right? So done. So like you just have to spend some time. Sometimes it's like it just clicks. Sometimes it will take some time for you for it to click in your mind. Okay, this is how you have to do it. Okay, fine. So we'll move on to the next question. Okay. Right. And next question is okay. There are a lot of good questions. Okay, so a 5% solution of cane sugar is having delta TF value, or no, that is having a freezing point TF of this freezing point value of 272.88 Kelvin. Right. Now, what they're asking is if I have a 5% glucose solution, what will be the TF of this, right? And remember, TF of water, freezing point of water, you need to take it as 273.15 Kelvin. Okay, so they're telling that 5% solution of cane sugar is having a freezing point of this much, and asking you, if I have 5% glucose solution, what will be the freezing point? %5 by mass. Okay, 5% of the solution by mass. So it's M by M. Okay, so you know the formula. Delta TF is equal to, I have to give you the KF value, isn't it? So KF value, oh, KF value is not given. That's the whole point of the question, isn't it? So delta TF is equal to KF into M, where M is the molality, right? So first you calculate delta TF for sucrose solution. Cane sugar is sucrose. Please remember that. When I say cane sugar, it is sucrose. Okay, right. So delta TF of sucrose you can calculate. That will be 273.15 minus 272.88, whatever be the value. So it will be 273.18 minus 272.88 is equal to KF. Now you're using same thing, right? Both cane sugar and your glucose, both are aqueous solutions. The solvent used is water. So what you're finding here is KF for water, and the same thing has to be used for the second time and the second solution. Okay, now they are given 5% by 5% M by M of cane sugar, right? You have to calculate the molality, right? So what do you mean by 5%? That means 5 grams of sucrose is there in 5%, right? So is there in 100 grams of solution. That's what it means, right? 5 grams of sucrose is present in 100 grams of the solution, right? Okay. Or you can do one more thing. Instead of doing all this, right? What you can do is they're asking. So see, there are two equations, right? This is one. The other one is delta TF of glucose is KF into M. Is it not? Right? Now you see, if it's a, oh no, it will be changing. Okay, you have to do it, guys. There is no easier way for this. Right? So I have to calculate what is the molality first. Let me calculate that. Right? So that means 5 grams of sucrose is present in 100 grams of solution. Right? So how will you calculate molality? Molality is number of moles of solute. Now I have 5 grams of sucrose. So can I say 5 divided by how much? I don't know how much. What is the molecular mass? 324 or 342? Okay. 5 divided by 342. Okay. That is the number of moles divided by total mass of the solvent. Right. Now you have 5 grams of sucrose and 100 grams of solution. Right. So what will be the mass of solvent? You have 5 grams of sucrose and 100 grams of solution. So what is the mass of solvent?
95 grams.
95.
Yeah, that's it, right? 95. So here it will be 95 grams into 1000. Okay, this is molarity of sucrose. Don't calculate, right? Why am I telling don't calculate? There's a sense. There is a thing, right? So what you do, this keep it as 1. This solution, I mean, this equation keep it as 2. So you just do 1 divided by 2. Okay, when you do 1 divided by 2, kf will get cancelled, isn't it? Because you're doing the same thing, right? So now you have delta TF of sucrose will be equal to, when divided by delta TF of glucose is what we need to find, is equal to molarity of sucrose divided by molarity of glucose. Molality of glucose, right? Now we have calculated what is this thing. So it will be 5 divided by 342 into 95 into 1000 divided by, now it's given the same 5% of glucose solution, right? Only thing which is going to vary is this molecular mass. Instead of 342, it will be how much? 180, right? So it will be 5 divided by, I think I'll write it like to the top. Okay, I'll write this here. So it will be 5 divided by 342 into 95 into 1000 divided by 5 divided by 180 into 95 into 1000. Right? So 1000 gets cancelled, 5 gets cancelled, 95 gets cancelled. So what you have is basically delta TF of sucrose divided by delta TF of glucose is equal to 180 divided by 342. That's it. This 180 will go at the top because you understand how the math works, right? This 180 will go at the top, 340 will come to the bottom. So it is 180 divided by 342. And you know what is the depression and freezing point for sucrose solution? They have already given. It's going to be 273.18 minus 272.88. That value, this value also you know. So you can calculate what will be the delta TF of glucose solution. Okay. So remember, whenever two different solutions are given to you, always try to divide them. That will save up a lot of calculations. Lot of calculations will save. See how much calculation we save. So many things cancelled out. Okay, keep this in mind, right? So now you'll get the answer to this question also easily, right? One more question. Okay, what is the time? Okay, maybe this will be the last question. Fine. Right. So hope you understood what you did here. We just did 2 times and then divided. That's it. Easy. But calculating molarity, you have to be very careful. If it's 5% solution, 5 grams of glucose and 100 grams of solution. Right? So if you have to calculate the molarity, number of moles would be 5 divided by 342 divided by mass of solvent. Mass of solvent is 95. You can use the calculator. 100 grams of solution, in that 5 grams of solution. So remaining will be solvent. Right? Okay. So moving on. Okay. So I have 6% by mass of solvent. What do you mean by this? If I say 6% of what do I have is basically urea, right? Okay. Right. So I have 6% by mass of solvent solution of urea. What do you mean by this? What can you tell about it? If I mention it like this, 6%. The percentage is in terms of by mass of solvent. Generally, what we do? We do it in terms of mass of
Solution.
generally solution. Correct. So what do you mean by this now?
6 grams of urea in 100 grams of solvent.
Absolutely. Right. So this means 6 grams of urea is present in 100 grams of solvent. Very important. That's what you mean by this. Okay. Right. Fine. Just because you see percentage, do not always use question reading is very important. Right. Very, very important. Okay. So what they're telling is 6% by mass of solvent of this urea solution is having delta TB as X1. Okay, is having an elevation in boiling point of X1. Same way, I have 18%, same thing, by mass of solvent of what solution? The solution is glucose is having delta TB of x2. This has some value x2, small x1, small x2, right? Now, when this and this are mixed, when both the solutions are mixed, now there I have the delta elevation in boiling point as x3. Okay. Now the question is, you have to find the relationship between x1, x2, and x3. Their options are given like this. Option A is x1 plus x2 is equal to x3. Option B is 3x1 plus x2 is equal to x3. Or you have option C as x1 equal to x2 equal to x3. Option D as x1 less than x2 less than x3, right? So you have to x1, x2, x3 are the elevation boiling points of the three solutions. X1 is for only the urea, second x2 is for only glucose, and x3 is for the two solutions mixed together. You have to find the relationship between x1, x2, and x3. Question only looks like complicated. It's not. It's very easy. Okay. So I think I'll
Sir,
help
is
you.
it option A?
Option A is x1. Where is it? Yeah, x1 plus x2 is equal to x3. Okay, I'm not sure. I'll check. We'll check. Right. Okay. Right. So first, let me calculate it for the first solution. 6% of urea solution by mass of solvent. Right. So I know this is the formula which I have to use. Delta TB is equal to KB into M. Only one formula. Right. So delta TB in this case is given as x1 is equal to KB into the molality. Molality I can calculate now. Okay. So it is given as 6%. That means 6 grams of urea is present in 100 grams of solvent. That's what you mean by this. So 6 divided by 60 is the number of moles of urea, right? Divided by the mass of solvent, which is 100 into 1000, right? So this and this goes to this thing's one time. Oh, what? Seriously? Am I right? Yeah, correct. So x1 is nothing but kb. Okay, right. So now if I go for the second solution is same thing. x2 is the elevation boiling point, kb is there, molality we can calculate. Now it is 18%, so 18 grams of glucose is present in 100 grams of solvent, right? So 180 18 divided by 180 into into what is this? 100 is the mass of solvent into 1000 into 1000 only, right? So again, everything will get cancelled. This will go 10 times. This and this will go in 18 again. So x2 is also equal to kb. Okay, now we'll see what happens. So until now, x1 is equal to x2 is what we got. So by this, don't decide x1 is equal to x2 is equal to x3. Calculate the other one also. We'll see what happens. Okay. So now when I go for the mixed solution, x3 is the elevation and boiling point. Kb into m, we have to calculate molality of the solution. So it's a two solution mixed. So I have two solutes now. Correct, right? So first solute is 6%. Number of moles will be 6 divided by 60 divided by 18 divided by 180. These are the number of moles of urea and glucose divided by total mass of the solvent. Remember, total mass is now 200, not 100. Okay, total mass of solvent is 100 from first solution, 100 from the second solution. So it becomes 200 now into 1000, right? So this will become 0.1, 0.1. So 0.1 plus 0.1 will become 0.2. So this and this will go, right? This and this will go 5 times. 5 into 0.2 is how much? What? Am I doing it correctly? Six divided by 60 is 0.1, and 180 18 divided by 180 is again 0.1. So 0.1 plus 0.1 will become 0.2. Total mass of
Sir,
solvent
it's
will become
option C.
option C. So it should be, yeah, above all the things are kb. Correct. So you see x3 is also equal to kb. Everything just gets cancelled actually. It's again 0.2 into 5 will become 1. Right? So what is the answer? x1 equal to x2 equal to x3 is what is the answer. All are equal to kb. Right? So again, an easy question. I just same formula utilized in different ways is what you need to understand here. Okay, so I'll wind up with this. So we'll do 2 problems on osmotic pressure and your Van 't Hoff factor tomorrow, and then we'll go for solid state. Okay, right? So I think if there's no questions, we can wind it up. Any questions are there? Okay, fine. Thank you so much, people. We'll meet tomorrow.
Thank you, sir.
Thank you, sir.
Thank you, sir.